Jean catches a bus to work every morning. According to the timetable, the bus is due 8 a.m. So the bus is due 8 a.m. So 8, the bus is due. Okay. But Jean knows that the bus can arrive at a random time between 5 minutes early. So 5 minutes early means the bus can come at 7:55 and 9 minutes late. 9 minutes late. This is minute. This is minute. That means the bus can come at 8 past 9. Okay. The random variable x represents the time in minutes after 7:55 am. Now, this could be tricky. The random variable is defined by time after 7:55 am. The bus can come at 8, is supposed to come at 8, but it come at 5 minutes earlier, or it can come 9 minutes later. But the random variable is defined from 7:55 am afterwards. So that means since the bus can come either at 7:55 or at 8:09, that makes it altogether 14 minutes from the starting point. Now this is a very important point. This is part of the question. Since the random variable is the time after 7:55 am, you have to mention it doesn't matter when the bus comes or how early it comes or how late it comes. A common mistake is to write it as -5 to 9, and it would be correct if the random variable was that the time is calculated from 8 a.m. but the time is not calculated from 8 a.m. The time is calculated from 7:55 a.m. So this would be wrong. So that makes the proper random variable uh, from 0 to 14. So suitable distribution, so it's a uniform continuous distribution, and properly defined is 0 to 14. You have to write it fully as the PDF. So it would be 1 by, the PDF is defined as from the interval. If the interval is A to B, then the PDF is 1 by B minus A. That means it would be 1 by 14 minus 0, and the limit is from 0 to 14, 0 otherwise. Okay, question number B. Calculate the means. The mean value is A plus B by 2, so 0 plus 14 by 2, which is 7. Question number C. Find the CDF. Now, the formula for CDF is integration. So since CDF is cumulative, integration has to be done. So CDF equals to integration of PDF. So it doesn't have any limit because we want an expression. So this would be 1 by 14 dx. So that would be 1 by 14x plus c. So the rule is lower limit, f lower limit, which is 0, equals to 0, or f upper limit, which is 14, equals to 1. So whatever you want, you can use it. So I'm going to use f lower limit equals to 0 because the total probability is 0 at the lower limit. Therefore 0, instead of fx I'm writing 0, and I'm putting 0 in place of x plus c. Therefore c equals to 0. Had I used f upper limit, f14 equals to 1, the answer would have been same. So that would be 1 equals to 1 by 14 into 14 plus c. This 14 cancels. C equals to 1 minus 1 equals to 0. It's the same thing. So the CDF has to be properly defined. CDF equals to expression. The expression is 1 by 14x, and the limit is 0 to 14. And the CDF is defined as above this we write a 0, after this we write a 1. This is less than the lower limit, and this is greater than the upper limit. So that's the CDF is expressed. The next question, Jean will be late for work if the bus arrives at after 8:05. Now you have to understand, one is the bus, when is the bus coming, and the other question is the random variable, which is after 7:55 am. So question number D is going to be, you have to understand the value in terms of x. X is after 7:55. If the bus is coming after 8 past 5, that means random variables from 7:55, and if the bus comes at 8 past 5, that makes it 10 minutes. 10 minutes from the definition of the random variable. So if the bus comes after 8 past 5, that means if it is longer than 10 minutes. So please be careful with the definition of the random variable and the story. So the probability should be x is greater than 10. Now this is continuous, greater than 10 or greater than equal to 10 is the same thing, makes no difference. Now in order to do this, it's a good idea to use the CDF from the previous sum. So CDF, we can write 1 minus x is less than 10. CDF by definition means x is less than 10 means F10. We can just plug in the value here. This is going to be 1 minus CDF is 1 by 14x. So this is going to be 2 by 7. This is a CDF. For finding the constant, the rule is, remember, CDF F upper limit is 1. So using the CDF, we can do this. We can write question number A. F upper limit is 2 equals to 1. Therefore, let's put the value here. K 2 squared plus 2k 2 equals to 1. That means 4k plus 4k equals to 1. Therefore, 8k equals to 1. K equals to 1 by 8. So using the rule of CDF, upper limit equals to 1. Question number B is finding the median. Now the rule for median is CDF equals to 0.5. CDF equals to 0.5. This is because median means it's the middle data. If this is median Q2, then it means 50% of the data is below and 50% of the data is above. So in terms of probability, we write it as x is less than median equals to 50%. That's how the median is written in terms of probability. So when we write x is less than something, we can just write it in CDF. So that is 50%. So that's why when we want to find the median, we can just write CDF equals to 50%. So that means fx equals to 0.5 for median. So therefore the expression is k is now 1 by 8, x squared plus 2k is 1 by 8, x equals to 0.5. If we multiply 1 by 8 with both sides, this will be x squared plus 2x equals to 4. That makes it x squared 2x minus 4 equals to 0. Now let's try to do this. We cannot do middle term breaks. We have to use the quadratic formula. Remember the quadratic formula. If you have ax squared plus bx plus c equals to 0 as a quadratic equation, then x equals to minus b plus minus square root of b squared minus 4ac divided by twice a over the entire uh, numerator. So this is going to be minus b, coefficient of x is plus 2, so minus b plus minus root over b squared is 2 squared minus 4a is 1 and c is minus 4. You have to include the entire value of c. C means the term without any x divided by twice a. So this will be minus 2 plus minus square root of, by the way, plus minus means since it's a quadratic equation, x has to have two values. So plus minus is for writing it in a shortcut. Instead of writing two values, we are writing it together. So plus minus root over 2 squared is 4, minus 4 into minus 4 is 16, plus 16 plus 16 plus 4 is 20 divided by 2. So one value of x is going to be minus 20 plus square root of 20. So minus 2 plus square root of 20 by 2, and this would be minus 2 plus square root of 20 divided by 2. This is going to be 1.24. 1.24. And the next one is going to be x equals to minus square root of 20 divided by 2, which is going to be minus 2 minus square root of 20 divided by 2 is going to be minus 3.24. Minus 3.24. Now we have two values of the median. Which one to use? You always have to check with the limit. It's from 0 to 2. So it is going to be answer median is 1.24. They didn't mention anything about decimal places or anything. 3 significant figure is pretty standard. Now we have to find the PDF. Remember, PDF is an instance of the probability. CDF is cumulative, that means total probability. So CDF, we have to find the derivative. So CDF is d by dx of PDF is d by dx of the CDF, which is k is 1 by 8 x squared. Then we have 2 into 1 by 8 x. So this is 2, 4 is 8. So when we differentiate, this will be 1 by 8. X squared is 2x plus 1 by 4. X is 1. So 1 by 4. So this is going to be 1 by 4x plus 1 by 4. It is very important to remember you have to define it. To define the PDF, you have to write it as an expression 1 by 4x plus 1 by 4, and the limit is from 0 to 2, so the limit will be the same, so 0 to 2, and in PDF we write anything else outside this is probably going to be 0, so 0 otherwise. Next question, sketch. So in order to sketch the PDF, we need two axes, x, and this is fx. So 0, the limit is from 0 to 2, so 0 to 2 when it is 0, 0 plus 1 by 4, this is going to be 1 by 4, this is going to be 1 by 5, and when it is 2, so 2 by 2, 2 by 4 is half, half plus 1 by 4, that is going to be 3 by 4, so you have another point here, and since we know this is a line, so we'll just join the line, so that's the sketch. Next question, number E, write down the mode. So this is D, and question number E. To write down the mode, you see the mode is the data with the highest frequency, so mode is 2. So this is the data with the highest frequency. Next, question number F, find the expected value. So the rule for expected value is expected value equals to total limit 0 to 2 x fx. So 0 to 2 x fx is 1 by 4x plus 1 by 4. So if we simplify from 0 to 2, it would be 1 by 4 x squared plus 1 by 4 x. So this is basic integration. 1 by 4 is constant, x cubed by 3 plus 1 by 4 is constant, x squared by 2, limit is 0 to 2. So if we put the value here, 1 by 12 2 cubed plus 1 by 8 2 squared minus 0 plus 0 is 0. So we can write 8 by 12 is going to be 4 by 8 by 12, 8 by 12 is going to be 2 by 3 plus 2 squared 4. 4 by 8 is going to be half. This is going to be half. So this is going to be 7 by 6. So it's going to be 7 by 6. So comment on the skewness of the data. So skewness means that the data is not symmetric, or is it symmetric? That's skewness. So it's commenting on the shape of the data. So for skewness, we need, it's good enough if we compare the mean and the median. So this is the mean, and if we know the median, this is the median. The median is 1.24 and the mean is 7 by 6, which is 1.17. So 1.17. Now you see that the median is more than the mean. So if you have the median and if the mean is more, then we say that the data is positively skewed. If the mean is less, we say that the data is negatively skewed. So we can write 1.24, 1.17. Since the mean is less than median, it is negatively skewed. A more complete definition of skewness would be to put the median at the center, and if the mean is here and the mode is here, which is, this is true here because the mode is 2, so the mode is greater than the median and the mean is less than the median. In that case, we can say negative skewness. On the other hand, if the mean is greater, automatically if the mode is less than the median, then we can say positively skewed. So in that way we can involve both the mean, mode and the median. So we can write mode equals to 2 and we can write like this also. That's also fine.